Hello guys, welcome back to Programming Programmers. So today we are going to discuss a problem, count triplets. So this will be the editorial of the problem and I'm going to link it in the description box, so don't worry, you will find it there. So let's first understand what the problem is. So this problem says us that we are going to have an array with n elements in it, and we need to find all such triplets such that x plus y equal to z. So this will be the condition. So let's say a triplet, what will be a valid triplet? So we are having a valid triplet as 1 comma 2 comma 3. Okay, why? Because 1 plus 2 is equal to 3, 1 plus 2 is equal to 3. So it satisfies the condition of x plus y equal to z. So this is the problem. So let's head towards the solution. So our solution, so for the solution we are going to do little bit of pre-processing before going to the main problem. So what our pre-processing will be, like let us assume we are given an array and our array is having name as ARR, and let's say its elements are 1, then 2, then 3, then again 1, then 0, then again 0, again 1, then again 3. So these are the elements in my array. So what I will do is I will make another array, and this array will be having a size of the maximum element in this array plus 1. So maximum element in this is 3. So what we are going to do is we are going to make an array of size 4. So 0, 1, 2, 3. So our array is of size 4. And what we are going to save in that array? We are going to save the count of particular element from the main array. So let's see what it is. So first of all, the count of zeros in our main array is 2. See, there are 2 zeros, 0, then this one 0. And now for 1 we are going to count the number of 1 in our main array. So we are having 3 ones. So we will just save 3. And we are having count of 2 as 1. So we are just saving 1. Then we are having count of 3 as 2. So we will save 2 here. So what f will save? F will save the count of particular element from the main array. Okay, so this is the pre-processing that we need to do for our problem. This pre-processing can be done in order and operation. We just need to traverse this array and we will just increment the count. We will just for initial stages we will just save 0 in this, and we can do that. Okay, so going to the problem, how we are going to solve the problem in this format. So we are having 4 cases here. So first discuss case 1. So what our case 1 will be, we are having our elements as 0, 0, 0. So this is one triplet. This will be a valid triplet because 0 plus 0 equal to 0. So we need to find the count of all such triplets from our main array. So how we are going to do that? We will do this with the help of permutation and combination. What permutation and combination says is, like from permutation and combination we are going to extract a formula of NC3. Okay, combinatrix NC3. NCR, generally it is NCR. So what NCR is? NCR says that we are having a set of size n, and we need to extract the R elements from that set. Then it can be generalized as NCR. So this is what NCR says is. So in our problem, n will be the count of zeros. Okay, so we'll write it as f of 0, then C, then 3. We need to find triplets, that's why we are writing here 3. So what it will be is, after expanding it, I have a shortcut to expand it, and that shortcut will be f of 0 multiply by f of 0 minus 1 multiply by f of 0 minus 2. So this is what most of us will study in class 11th or 12th, and this is really simple, divided by 1 into 2 into 3. So this will be the formula. Don't worry, I will also add links to study NCR, to just study this thing. Okay, so you will get a better clarity if you don't have of this thing. So NCR in general says that NCR expands to n factorial upon r factorial into n minus r factorial. So we don't need to calculate these factorials because we can straightforward do this. Okay, so this will be the case 1. So this is going to be an order 1 operation. This is a straightforward formula, then this is going to be an order 1 operation. Then going to the case number 2. So for case number 2, we are having our elements as 0, x, x. Okay, so this is also a valid triplet. Why? Because 0 plus x equal to x. So by thinking it in terms of permutation combination, we can definitely say that this is going to be f of x, like count of all the x's, c2. So we need to extract these two x's. Okay, we don't need to deal with 0 here, so we will just find out fx c2, and then we will multiply it by f of 0. Why? Because this will also matter, like these will help in finding out the triplets. Like assume we are having 2 2's. Okay, we are having 2 2's. Let's come to here. We are having 2 2's as well as 2 0's. So our valid triplets will be 0, 2, 2, as well as one more triplet will be 0, 2, 2. Why? Because 0 is coming twice. So this is how we will find out. So this is what I did here, f of x c2 multiply by f of 0. So f of x c2 you can find out by f of x multiply by f of x. Please don't mind my handwriting. I am just trying to make this video as short as possible, that's why I'm writing like this, and then divided by 1 into 2, and then multiply by f of 0 here. Again, yes, so then we will multiply by f of 0. So this will be, so for finding for case number 2, it will be an order n operation, because we need to go for a for loop for I equal to 1, I is less than equal to maximum element from our array, then I plus plus. So this loop will make it an order n operation. Then we will go for case number 3. For case number 3, what we are having is, we are having x, x, 2x. So this will be our case number 3. So how we are going to solve for this? Definitely x plus x equal to 2x. So this will be a valid triplet. So for this, what we are going to do is, we are going to find f of x from above. It must be clear to you. F of x c2 multiplied by f of 2x. We are going to find f of multiply f of 2x. So f of x c2, as we have calculated above, this is f of 2, fx c2, and we will multiply it by f of 2x. So you can do this step, and this will again be an order n operation. Why? Because we need to again run our for loop from I equal to 1, I is less than maximum element, I plus plus, because we need to find all such elements. Then we will go to case number 4. This will be our final case, and this is the most general case. So this case says that we are having x, y, x plus y. So we are having our triplets in this format. So how we are going to do for this? So what we are going to do is we are going to take a for loop for I equal to 1, I is less than equal to maximum element, then I plus plus. Okay, so we are taking a for loop from 1 here as well as in case number 2 as well as in case number 1, case number 3. Why? Because we have already covered for I equal to 0 in our case number 1, so we don't need to repeat that. That's why we are doing like this. We are going for I equal to 1, I is less than maximum element, then I plus plus, then again a for loop, a nested for loop, then this will go for j equal to I plus 1, j less than equal to maximum element, then again j plus plus. Now in this what we are going to do is we are going to for calculating, what we are going to do is we are just going to f of x multiply by f of y multiply by f of x into y. So this will find out the valid triplets for us for given x and y. If we are not having x plus y, this is not x into y, this is x plus y. That's a mistake. So this is going to be x plus y. So if we are not having x plus y, this much big x plus y, then it will create a problem. So we are again going to nest it inside an if condition, and that if condition, so this block will come under an if condition, and that if condition will be, first of all, we don't want to take I and similar values for I and j, and that is taken care by j equal to I plus 1. Why? Because it will come under case number 3. So that's why we did j equal to I plus 1. Then after that our condition will be if x plus y is less than maximum element. If x plus y is less than maximum element, then only we will compute like this. Otherwise we will not compute like this, we will get segmentation fault because we are not having x plus y in our this array. Alright, so this is how we are going to compute in this step. So what is actually happening here? We are having count of x, we are having count of y. Like I say, you are having 3 2s and you are having 2 3s, and then you are having 4 6s. Okay, so you are just going to multiply them now. Then you can get the number of triplets that can form out of them. So give it a thought, you will get it definitely. It will just take some time if you are not getting it, and that's also fine. Okay, so this is how we are going to compute for case number 4. So this will be an order of n square operation. So this is the deterministic operation. Complexity of this is order of n square. So this is a deterministic operation for our problem, and our problem is running on space complexity of order of n. Why? Because like order, not order of n, order of maximum element. Whatever be the maximum element in our array, so our space complexity will be depending on that, because we are providing it an auxiliary space of maximum element plus 1. That's why. I hope you can easily code it now, and you can easily get the concept behind it. Thank you.